After knowing how to write the complex numbers, we have to move to the another subtopic, that is set of complex numbers. Set of complex numbers is denoted by $math $bb and is written in the form of $a plus bi where a and b are real numbers. In this diagram we show how to write the set of complex numbers. From the previous slide we have the imaginary unit is I square, that is equal to -1. Therefore, every real number is a complex number where imaginary part will be the 0. That is b is equal to 0. Meaning the set of complex number is a superset of real numbers. The two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. For example, if a plus bi is equal to x plus yi, then a must be equal to x and b must be equal to y. Here we show the equality condition. If z1 is equal to a plus bi and z2 is equal to x plus yi to be equal, provided z1 is equal to z2 of the equation, the real parts are equal, that is a is equal to x and the imaginary parts are equal, then b is equal to y. The integral powers of iota follows four steps, that is I to the power of 1 is equal to I square is equal to -1 and I cube is equal to -I and I to the power of 4 is equal to 1. To find a higher power, divide the exponent by 4 and use the remainder to determine the result. For example, I10 is equal to I square is equal to -1, because if you divide 10 divided by 4, the remainder is 2. Therefore, I square is equal to -1. This pattern repeats for all the integral powers. After finding the integral powers, we have to find I to the power of n for larger value n. In this we have two steps, that is, in first we have to divide the exponent by 4. In this we have to divide exponent n by 4 to get quotient and a remainder. And in second step we use this remainder to find the value of in, which is same as ir, where r is the remainder. If the remainder is 1, then I to the power of n is I. If the remainder is 2, then I to the power of n is -1. If the remainder is 3, then I to the power of n is -I. And if the remainder is 0, then I to the power of n is equal to 1. Welcome back from the previous slide. Here we have positive integral powers. I to the power of 1 is equal to I square is equal to minus 1, I cube is equal to I square into I, that is equal to minus 1 into I, that is equal to minus I to the power of 4 is equal to I square into I square, that is equal to minus 1 into minus 1, that is equal to 1. I to the power of 5 is equal to I to the power of 4 into I to the power of 1, that is 1 into I, that is equal to I. I to the power of 6 is I to the power of 4 into I to the power of 2, that is equal to 1 into minus 1, that is equal to minus 1. After finding the positive integral powers of phi, we have to find the negative integral powers. That is, negative integral powers of iota follows the same repeating cycle of 4 values, that is 1, I, minus 1 and minus I, but are calculated by taking the reciprocal. For example, I to the power of minus 1 is 1 by I, which is simplifies to minus I. That is, to find any negative power, convert it into a positive power and use the pattern. Then I to the power of minus 1 is minus I to the power of minus 2 is minus 1, I to the power of minus 3 is I, and I to the power of minus 4 is 1. After knowing the negative powers, we have to calculate the negative powers. For calculating negative powers, we use the reciprocal rule, and then we have to simplify with the reciprocal. In reciprocal rule, we have a negative exponent means taking the reciprocal of the base, that is I to the power of minus n is 1 by I to the power of n. Simplify with the reciprocal means to find the value of 1 by I, we have to multiply the numerator and denominator by 1 by I into I by I, that is I by I square. Since I square is equal to minus 1, this becomes I by minus 1, that is minus I. After that, we have powers of I repeat in a cycle of 4, that is I to the power of 1 is I square is minus 1, I to the power of 3 is minus I, and I to the power of 4 is 1. To find a negative power, you can use the reciprocal rule and the cyclic nature of the powers of I. I to the power of minus 1 is 1 by I. To simplify, we have to multiply the numerator and denominator by I. Then we get 1 by I into I by I, that is I by I square, that is equal to I by minus 1, that is equal to minus I. After that, I to the power of minus 2 is equal to 1 by I square, that is equal to 1 by minus 1, that is equal to minus 1. I to the power of minus 3, this is equal to 1 by I cube, that is equal to 1 by minus I. multiply the numerator and denominator by I, we get 1 by minus I into I by I, that is equal to I by minus I square, that is equal to I by minus of minus 1, that is equal to I by 1, that is equal to I to the power of minus 4 is equal to 1 by I to the power of 4, that is equal to 1 by 1, that is equal to 1. With this I will conclude my session. Those who are having any doubt or clarification in this session, you put a comment in the comment box. I will rectify the same. And those who didn't watch my videos, I'll put the link in my description box. You can click on the link and see the videos.